Hello everyone, and welcome back to our data structures with Python. We're going to look today at removing a node from a linked list. In the previous lectures, we looked at how to insert a node at the beginning, the middle, or the end of a linked list. And we ended up with the linked list that we are seeing right here in front of us, starting with the head or the root pointing towards 0, 99, 3, 5, 4, then 9. What we're going to look at today is fairly simple. We're going to create a method that is going to receive data or a key. So if I want to delete this node in here, I'm going to give the number 3, the data of the linked list, of the node, in the linked list, and our function is going to delete it. So we have different types of removal. When it comes to nodes, we can remove based on a node. So I can give a node, an entire node, and say remove it, or I can give a key, data, and say remove whichever node that has this key. And this is what we are going to do today. So I'm going to start just by adding a simple comment: delete a node based on its key. So when we use the value or the data of a node to delete it, we call that value the key, because we're going to search through our linked list to find that node based on this data. So it is the key to finding it. And let's start with naming it. Let's call it just delete. So define delete. And we're going to start with the important things. What do I need to send to such a method? Of course, we're going to have self, that is a given by now, but from the name, we're saying I can delete a node based on a key. So I should receive that key. And that's it. It's fairly simple. Next, what I want to do is start by looking at the beginning or the start of my linked list. And as we have said this many times before, the head or the root always points towards the first location. So I'm going to create a temporary node, and I'm going to call this node temp for temporary. And I'm going to say, look, let's start at the beginning. I want to start at the beginning and then look through all of the nodes in my linked list to find the data that you sent to me, the key that you sent to me. So if I send the number 99 and say I want to delete the node with 99, I'm going to start here at the beginning and say, is this 99? No. Jump here. Is it 99? Yes. Delete it. And this is what we are going to do. So what I want to do is say temp, which is my temporary node that I'm creating, equals self.head. I want to start at the beginning. Then I'm going to ask a question, a very simple question. What if the first element was the element that I want to delete? What if the first node in here was the node that I actually wanted to delete? So let's say that if a user right now of our application sent the number 0 and said, I want the node with number 0 to be deleted. What are we going to do in this case? Well, let's check for that. Now, you might say, why are we checking for this right now? Why not just jump through all of them? Because this is a special case. If I want to delete this node, the one with the number 3 in it, what I want to have is actually 2 pointers. A pointer pointing here and a pointer pointing here to the node before it, so that I can say, look, I'm here. I want the pointer before me to point to the node after me. And that is going to make this connection from 99 to 5 and thus deleting number 3. When we look at the first element, we don't have that because I don't have any nodes before it. It is the first node. And that is why it's a special case, and I need to have a special type of processing for it in my method. And it's actually very simple. It's just an if statement. I'm going to say if temp.next, if my next pointer, by the way, let's start with normal processing. I'm going to start from here all the way to here. So this is normal traversing. And I'm going to say the following: if temp.next is not, and I can use not equal. Actually, I'm going to use it later in my code. It's not that big of a problem. It's the same thing. Python can take so many ways for the same type of code or for the same code. And what I'm going to do in here is look for none. Now I'm saying if temp.next, look, right now temp is here because I said temp equals self.head. So temp equals self.head. This is temp right now. And I say if temp.next, if the next part is not none, so there is something else. There's something right after it. What I'm doing in here is I'm checking if my linked list is made of just one element. Okay, because if it was made of just one element, then this element, this node where I'm right now, the temp node, is going to be pointing towards nothing or none. And this is exactly what I'm asking for in here. If temp.next, if it's pointing towards, is not none. So I'm asking, is there something after it? And yes. So if there is something after it, if this is not the only node in my list, what's going to happen is I'm going to ask if temp.data equals the key that I set. I'm asking if this temp. So right now, look, what we asked is the next none? Is this none? No, it isn't. And I'm saying is not none. This is exactly what I look for. Okay, let's give a simpler example, just to make this if statement more clear. Let's say that this is my linked list. Okay, and I'm going to create fairly simple node. So what this in here represents is a linked list with just one node. Let's say that this also had number 0 in it. So this number 0 is going to have the size of 16, just to make it a little bit clearer. So look at this if statement in here. It says if temp.next is not none. Okay, why am I asking about this? Because in this case where temp.next is none, so this is not going to work. This if statement is not going to work. That means I have just one element or just one node in my linked list. And to delete this, it means all I have to do is write head equals none. Because what I want to do in this case, there is no delete. I mean, there is no connection to the next node. All I have to do is just delete. So this is exactly what we're asking for in here. We are asking, is this alone? Is this node a lone node? Or is there something else after it? And we are asking, is there something after it? Because we are asking, is this not none? Okay, so when this condition in here is true, that means I have this type of node of linked list instead of this. Okay, so since we are asking for it and it is true, the next if statement is going to ask for the node itself. Now what I want to do is this if statement in here is checking for, is my linked list made of multiple nodes? This if statement in here is checking to see if the first of all, since we are in this location, then we have this type of linked list, not this one. And we are now asking if the first element is the one that we should delete. So what I'm going to do is I'm going to say, if it was the first element, if the first element temp.data is equal to the key, the data of it is equal to the key, then what I want to do is make it just jump. Self.head equals temp.next. What I'm saying in here is Look, hey, head, self.head. Where is the temp looking at? Where is the next point? And it's saying temp.next equals 99, this location here. And this is exactly what we're saying. We're saying self.head, let it equal what the temp is pointing towards. So this is going to do the following. And that means that we just deleted this node in here. Now, some of you might say, but we still see it. That's because we're humans and we're looking at this as an image or as a graph. In reality, the computer is going to look for the head and say, where are you pointing? Oh, you're pointing here. Where are you pointing? Here, 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 and it's done. So from the computer's point of view, this is actually deleted. But we're going to add something else to make this better from a memory's point of view. We're going to say temp equals none, deleted by head. So what we are doing is actually this. Okay, so what we did in reality was, first of all, what we want to do is look at the head and say, if, look, this if statement, are we a big linked list or a linked list with one node? Since we are in here, that means true. That means this is a big linked list. We ask the next question, which is the first element or the first node the one that I'm looking for with the key that I sent? If it is, then hey, head, instead of pointing here, point towards where temporary is pointing towards. Right now you can see in here, temp is pointing towards 99. And when we say head equals temp.next, what we are doing is this. Then we say temp equal none. I want to delete it, even if the computer right now is starting like this, but in reality, the memory still have 0 in it. And what I want to do is temp equal none to delete it. Now, that is the case for when the key that I'm looking for is in the first node. But what if it wasn't? Well, this question, the if statement is saying, are we in the first location? And we just said, yes, do this. No. Well, we're going to search throughout the linked list. What we mean in here is this question in here, it's saying, if this question is true, if temp.data is key, that means the key that we are looking for is the first element. It's this one in here. But what if we send the number 5 and it came and asked, is temp.data, which is 0, equal to the key that we sent, which is 5? Is this equal to 5? No, it isn't. So it's not going to process this part, but it's going to jump to the else. Now in the else, what we want to do is start to jump or traverse our linked list or jump through the node. So I want to start here and jump, 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 all the way until I either find the key or end at the end of the list, which means I search for a key that is not here. For instance, if I search for the number 1 right now, this is not 1, not 1, not 1, same, same, same. There is no number 1. So I want to jump, 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 jump. When I reach none, it means number 1 is not in this list and I cannot delete it. Or if I'm looking for number 5, then I want to jump, jump, jump. This is 5, delete it. This is exactly what's going to happen in this else part in here. So what I want to do is just start with the normal traverse. I'm going to start and say, while temp.next, I can say is not, but I'm going to use the older method just to mix things up. Is not none. And I'm saying, look, while temp.next is not none. So is this none? No, there's something. Is this none? No, no, no. Then in here, while temp.next, and this is the next. This is actually pointing towards nothing or none. So this while loop is going to break when we reach the last location or the last node in our linked list. Now, I'm going to ask another question, which is a simple one. If temp.data is equal to the key, Then what I want to do is break. Give me a few seconds. I'm going to explain this. Previous equals my temp, and temp equals temp dot next. Now, the reason that I wrote this and then trying to explain is because it's kind of backwards. The idea in here is the following. Let's take as an example number 5. Let's say that we are looking for this node to delete it, the node with the key of 5. Okay, and we came here and we asked, is this linked list, is it made of just one node? And we said, actually no, it's made of more than one. Okay, this is the part of the more than one. Is it the first location? Is this the first one? Is 5 in here? No, it isn't. So it jumped from this if to the else and started to say, okay, I'm going to keep on jumping until I either end my linked list or find the key. So what happens in here is, well, temp.next, right now temp is here. Actually, let's switch this. I'm going to use this small triangle as my next, my temp. So temp is pointing towards here because we said temp equals head. So temp and head pointing towards the same location. Then we ask, is temp.data, is this data, is it equal to the key? And the key that we are talking about right now is number 5. So is temp.data equal key? No, 0 is not equal to 5. While temp.next is not none. So this is just a normal traverse. It's going to make me jump from the first location all the way to the end. And I said, is temp.data equal to the key? Right now, is 0 equal to 5? Again, no. So this break is only going to happen, it's going to break the while loop only when the data of the temporary is equal to the key that we sent. And right now 0 and 5 are not equal, so this break is not going to happen. So it jumps from here to here and says previous, and I'm going to use this shape, rhombus shape. I'm going to use it to say, okay, previous equals temp. So where's temp pointing? Temp is pointing here. Previous is going to point towards the same location. Okay, then we say temp equals temp.next. So temp right now, this pointer should point to where it is pointing. So this is temp, as we can see, it's pointing towards it. Where is the next? This is the next. And we say temp equal temp.next. So what we do is this. And now it's going to come back again in here and ask, is temp.next not equal to none? Is this not equal to none? Yes, this is not none. So what happens is it asks the same question again. Is temp.data is 99 equal to the key to 5? No, it isn't. Previous, look, previous equals temp. Where is temp pointing? It's pointing here. So previous equals temp. It's pointing towards the same location. Temp equals temp.next. And it's saying, where are you, temp? I'm here. You equal the next of you. Okay, so this is the next of temp. So exactly this is what happens exactly. And it's going to ask the same question again. Is this is the next none? No, it isn't. Is the data equal to the key that we sent, which is 5? No, it isn't. Don't go through the break. Previous is equal to temp. So again, same thing. It's going to take the pointer, point toward the same location. Temp equals temp.next. Now, if we reached actually the location where, if we ask this question like temp.next is not equal to none, yes, it's not equal to none. There's something in here. Is temp.data equal to the key? Is temp.data equal to the key of 5, which we already sent? Yes, it is. So this break is going to work. Now, at this point, the while stops because there's a break. It's not continue. It's a break. Stop your loop that you're in, and this is not going to be executed because I'm going to jump from the break all the way outside of the while. And as we can see from the space in here, this line and this line, all of those lines are inside of the while loop. So when I jump, when I break outside of it, all of them will stop. I'm not going to execute them. So previous is right now, look at the location. Previous is pointing here to the, it's called previous, it's right before it, it's previous to it, and temp is pointing towards where I want it to, which is the location that I want to delete. What I'm going to do in here is do two things, because this while loop is going to stop in one of two cases only. One, if it reaches the end, if temp.next equals none. So if let's say that I looked for number 1. So this is not 1, not 1, not 1, and temp said not 1, not 1, not 1, jump. Is temp.next not equal to none? This condition is not going to work anymore, so it's going to stop. That is the first method to stop this while loop. The second method is the break that we just did, is when we find the data and we want to break. So what I'm going to do now is I'm going to check for both cases. I'm going to check for the first one, which is, let's give it a simple simple comment, which is node not found. And what I'm going to do in here and say if temp my node is equal to none, then let me just put this in here, then just return. Okay, so what happens in here, so many mistakes. Okay, so what happens in here is the following. I said there is two ways that this while loop is going to end. Either we reach the end of it, or we reach the location or the node that we're looking for using the key. So I'm going to search for both of them. When I say if temp is equal to none, that means that my temp is going to look here, 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 does not find the key, go here, and stops. So this return is going to stop the entire function, just like this break stopped the entire while loop. It's going to stop the function and return us to the main program because, well, the key that you found or that you asked for is not here. And we can actually add something in here like a small display, a small print message that can say the key you entered is not in the linked list or cannot be found or anything of the sorts. Okay, and this is the first case. The second case, which is if we found the key, and because we found the key, we broke the while loop. That is the second case that we are going to look at in here, which is, let's call it, we found it. This is just a comment, as you know, and I'm going to say previous dot next. Let's look at it from a pointer's point of view before we write the code. If I want to delete number 5 right now, and I have temp, which is pointing towards it, and have previous, which is pointing right before it, the simplest thing that I can say is, hey, you, previous dot next. Instead of pointing here, you should point towards where temp.next is pointing. So right now, temp.next is pointing towards 4. And I can say previous.next equals temp.next. So what I'm saying is you take this connector in here and point towards 4. And that is exactly what we're going to do, which is previous.next equals temp.next. Then return, stop the function, return to the main program. So in reality, what we're doing right now is saying, if I want to do this in reality, this is the key that I stopped at, which is number 5. And I have a temporary node or a temp pointer that is pointing towards it, and I have a previous pointer pointing towards the node right before it. And I'm saying the following: previous.next, this next point toward where temp.next is pointing towards. So temp.next is pointing towards 4, and I'm going to do the same. And this in reality means that we just deleted it, because we are going to start here 0, 99, 3, jump to 4 and 9. So 5 is hidden. And I can do this as well. I can do temp equals none, and that is just to delete it, to do this. Now, when looking at something of the sort of like temp equals none, this type of delete, remember that Python have an automatic data or garbage collection. So it is going to delete those types of information that are not connected to anything anymore. But at the same time, always remember that manually deleting those types of data that remain in your system is going to be much faster, because you're letting the computer process less information as it is working. So let's go back to our program and check to see if this is actually working. Okay, so let's check. We ended with, I'm going to run it. We ended with 0993549. This is from our last program. And what I'm going to do in here is before printing, or actually after printing, let's duplicate the printing. Let's go for list.delete and give it the key. So let's go for number 5, as we did. Now, if I delete it in here, let me just do a simple print. This is just to get a new line between the two, and you can see 09935 is deleted. Okay, what if we specify number 1? We don't have a number 1. Okay, so this is not working. Okay, it's actually deleting the last one, even if it's number 1, which means it is the condition for stopping. Let's look here while not temp.next, while temp is not equal to none. That is because if it is temp.next, then it will never reach the end. It will stop at the last node, but not jump to it. We want it to jump. Let's run it again and see. The key you entered is not, okay, so right now it's working. The key you entered is not, which means 0, and you can see that because we entered number 1 in here, it's not anywhere to be found. There is no number 1 in our linked list. It showed this message that the key entered is not within the linked list, and nothing is deleted. So that is for deleting an item or a node based on the data of it, the key of it. And the next very, very short lecture, we're going to look at how to pop a linked list or dequeue it. So we're going to look at how to delete from the first and last locations. We're going to see in detail how to delete something from the beginning of a linked list, and it's going to be an assignment for you to finish that with deleting an item from the end of a linked list. Thank you so much for listening, and I'm going to see you on the next lecture.